All right, dimensional analysis or converting units. So what is it? How do you do it? Let's talk about it. So here are your standards, your objectives, performance indicators, all that good stuff. Pause the video if you really want to read it. All right, so what's a conversion factor? That's what you really need for dimensional analysis. It's a simple ratio that relates two units to each other. So for example, 1 meter equals 1,000 millimeters. So that's an example. But you're going to show it as a ratio, and it expresses a measurement of the same quantity. So that means 1 meter and 1,000 millimeters are exactly the same thing, just different units. The top and bottom of that fraction of that ratio are equal. So here's some examples. So 1 kilogram equals 1,000 grams. 1 liter equals 1,000 milliliters. 1 hour equals 60 minutes. So it's not all about the 1,000. You could have 1 meter equals 100 centimeters. Okay. 1 centimeter equals 10 millimeters. Those are all conversion factors. But when we write them as conversion factors, we write them like this. And either the kilogram or the gram is on the top, or it could be the reverse, and it depends what you're trying to convert. But regardless, that fraction is 1. Okay, so that ratio, that conversion factor is 1. Okay, so derived units. Let's talk about them for a minute. I won't test you on this, but I think it's just an important concept to understand. So they're units that are derived only by multiplying or dividing the other base units. So for example, area is length times width. So meters squared is a derived unit. It's not a measured unit. You don't measure in meters squared. You measure in meters, but you get the derived unit of meters squared by doing the area formula. Same with volume. The derived unit is meters cubed. Density, the derived unit, grams per centimeter cubed or grams per milliliter. Okay, so again, you only get derived units by doing the calculations with measured units. All right, so we're going to tie those last two together where I talked about density. Okay, so here is a visualization of a liter. So a liter would be 10 centimeters by 10 centimeters by 10 centimeters as a cube. And then one individual little piece would be a cubic centimeter. So a liter is equal to 1,000 centimeters cubed. So a liter, we also know from previous information, hopefully, is that a liter is 1,000 milliliters. So 1,000 milliliters equals 1,000 centimeters cubed. So essentially 1 milliliter is 1 centimeter cubed. So if you look at table S, the units for density are grams per centimeter cubed, but now you should know that you can also say that is grams per milliliter. So those units are interchangeable because a centimeter cubed is the same measurement as a milliliter. Again, grams per centimeter cubed is the same as grams per milliliter. All right, so let's practice some conversions. Now, before we do dimensional analysis, let's use the staircase. Okay, so this is the staircase. If you forget how to set it up, use table C, and I'm going to show you how to do that. Okay, so first you need to start with base units. You need to put the base units at the center of your staircase. Then if you look, the first thing that you can see, all right, so I'm going to mark this here. The first thing you could see, K, kilo, and the factor is 10 to the 3. Okay, and so that means from the base unit, I'm going to go up 3. Now it doesn't tell me what to put here, so I'm just going to put a blank box. Okay, and then I'm going to put kilo 10 to the 3rd up here on this box. All right. The other up prefixes are not here. So if you don't want to put them in there, you can just leave them blank. You still need the space because that's going to be important, but you don't have to put any labels. All right, so next is deci. So let's just swap this color. Okay, deci was next. That is 10 to the -1. So that means down 1. So put a box and put deci. Okay, next is centi. And centi is down 2. Okay, so from base units down 2, label centi, 10 to the -2. All right, and then milli. Okay, milli, 10 to the -3. Oops. and that is down 3. So this table C allows you to build this staircase so you don't have to memorize it. Now micro, nano, and continue on. So if you wanted to add additional downstairs, you can, but this is just for most of the conversions that we're going to do. This is the only staircase you'll need. All right, so here's the staircase. So here's a conversion. So 10 kilometers equals how many meters? So I'm starting with K, kilo. That's where I'm starting. I need to get to meters. That's right there. So I'm going to go move, count how many places I would have to move to get there. So I moved 3 boxes to the right. So I have to move the decimal 3 places to the right. There's no decimal in 10. So remember, if there's not a decimal, we assume it's at the end of the number it's after the 0. So we're going to add 3 zeros, and there's going to be our answer, 10,000. All right, let's try another one. 10 centimeters. We're starting with centi. We're going to meters. Count how many places. We move 2 to the left, so you move the decimal 2 to the left. And again, there's no decimal in 10, so remember it's after the end on the right side of that 0. So move the decimal, and you're going to get 0.10. You put that 0 just as the placeholder, the leading 0. Okay, 27 meters. So we're starting with meters, and we're going to millimeters. Move how many boxes you need, count those places, 3 to the right, move the decimal to the right. Again, there's no decimal, so we add 3 zeros to the end. All right, 8.3. So we're starting with meters, and we're going to kilo. Count, that's 3 to the left, so we move the decimal 3 places to the left. We see the decimal between the 8 and the 3, so move the decimal 1, 2, 3 places to the left, and then add that leading 0. Okay, so now you try 14.51 centimeters to millimeters. See if you can figure it out. So again, we're starting here, going here. That should have been what you got. Okay, 8.23 centimeters to kilometers. So figure out where you're starting, where you need to get to, count, and then move the decimal. So you should have started here, moving all the way up to there. And that is 5 places, so you should have moved 5. Now we're going to practice using dimensional analysis. So the staircase doesn't work for everything. It doesn't work for time, for example, 60 seconds in 1 minute. I can't move the decimal to do that. Okay, 60 minutes an hour, can't move the decimal to do that. Okay, and some people just prefer it for the other calculations, and we'll need dimensional analysis when we move on. So here's how you do it. So I have 1.5 liters is how many centiliters. So I need, what conversion factor do I need? Well, I need to know that 1 liter is 100 centiliters. Write the number you're given, 1.5 liters, put it over 1. Multiply by the conversion factor. The units you want to end up with should be on top. So I know I have 1 liter and 100 centiliters, and either one of them can be on the top. I can flip it whichever way I need. In this case, I need the liters on the bottom. Why? Because when I do this calculation, I want to be able to cancel this and this, because remember in math, if it's on the top and the bottom, it cancels out, right? So they cancel out, and I'm left with 150 centiliters is my answer. All right, so 27.6 decigrams is how many grams? So what conversion factor do I need? I need to know decigrams to grams. Okay, so 1 gram is 10 decigrams. Write the number you're given over 1. Put the conversion factor the right way, right? So flip it the right way. Then you get to cross those out, and you can then multiply. In this case, I take 27.6 and divide it by 10, and there's my answer. And here, again, decide what conversion factor you need. I need kilometers, kilometers to meters. I know this is the conversion factor. I write what I was given. I flip it the right way so that I have kilometers on the bottom so that I can cross them out, and then I can solve. All right, so this one, I have to use conversion factors. I couldn't use move the decimal way. Why? The conversion factor is 1 minute equals 60 seconds. So there's what I was given. Flip the conversion factor the right way, cross it out and solve. Again, with time, you're not going to be able to do the move the decimal. Okay. And then here is some practice. Okay, so you can try to do these calculations on your own. And in class, we'd be doing a blue kit. And now hopefully you know how to use conversion factors now to convert in the SI system. Remember with prefixes, and if we're just doing the staircase, you can just move the decimal. You have to do it with dimensional analysis if you're using time or any other calculations that we'll be doing later in chemistry.